but please take notes so that you have two ways to possibly graph these sine and cosine curves with all the different translations that we can do. So here we have an example. I have two problems to do with you guys, so you can see how that'll work. And this is the first one. F of x equals 5 sine of pi over 8 times the quantity x minus 12 plus 10. So this is every transformation that we have where this number in front of the sine or cosine is the a, that tells us the amplitude. We have the b, that's the number in front of x. And then we have an h and a k. The h is the horizontal shift of our curve, and k is the vertical change in our sine or cosine curve. Just like yesterday, we're going to start with the k value. We're going to graph our sort of vertical axis. And so this function has been shifted up 10. So our new center of our curve, our new midline is what I called it yesterday, starts here at, let's say, 10. So that is our k value. Whatever is on the end there is that k value. And then what's our maximum value going to be of our curve? Yeah, so from yesterday, we get to add the amplitude, add that a value to get the maximum of 15. So there's our maximum. And then what's our minimum? Yeah, so that's 5. I'll put that right there. That's a 5. And so we can start with that k value and add the amplitude and subtract the amplitude to get our maximum and minimum. So there's our vertical axis. That's easy. No big deal. So from that midline, I'm just going to make this sort of dotted horizontal axis. And what we need to figure out then is I need you to graph one period of our sine or cosine curve. And it has been shifted horizontally. So that's what the h does. So yesterday I said, hey, how does that h shift our graph? What does x minus 12 do to the curve? Left 12. Does it left 12 or right 12? Right 12. It's always opposite, right? Left, right, okay. So this, we said yesterday, definitely shifts us right 12 units. But there's another way to deal with it, because we also have a period stretch or shrink, so that like spring is stretching and compressing. What I'm going to do, all of these changes that are trapped inside our sine function, they affect that x-axis. And so a very good way to figure out where one period starts and ends is to compare it to a normal curve. Normally starts at 0, and where does a normal curve end? 2 pi. So it starts at 0 and ends at 2 pi, and all of these changes are affecting that 0 to 2 pi. So what we can do is we're going to create a compound equation that starts, originally we started at 0, and originally we ended at 2 pi for a normal, boring sine or cosine curve. It normally starts at 0 and ends at 2 pi. All of these things that are inside that sine function, that are inside working on the x, go in the middle. So pi over 8 times the quantity x minus 12, I'm going to put that in the middle. This is a compound equation. You guys have solved compound equations before with inequalities. You've solved compound inequalities. This is a compound equation, okay? Now, what I want to do, there's a couple ways I could solve this. I could distribute the pi over 8. I don't want to. The easiest way is to get rid of the pi over 8. How can I get rid of the times by pi over 8? Yeah, divide. I could divide by pi over 8, but I don't like dividing by fractions. What can I do instead of dividing by a fraction?
Multiply by 8 over.
Multiply by the reciprocal. So I'm going to multiply both sides by 8 over pi. And again, you have to do it to every side. So instead of dividing by pi over 8, it's the same thing to multiply both sides. Scott, are you paying attention? Because you should. This is so much easier. It's more straightforward. So I'm going to multiply both sides by 8 over pi. What is 0 times 8 over pi? 0. Hey, look at that. In the middle here, these crossed out, so I'm just left with x minus 12 equals. And then what happens over here on the right-hand side? The pi's cancel, and we get 16. You'll notice, well, I'll talk about that in just a second. Now, again, I want to get x alone in the middle, so what do I need to do to get x all by itself? Yeah, add 12. So, and we're going to add 12 everywhere to both sides. And so now x is alone in the middle. 0 plus 12 is 12, and 16 plus 20 is 28. So this is one cycle of our curve on the x-axis. So this is my starting and ending point of this particular function. Does that seem easier than what we were doing yesterday? So this is one cycle or one period of our sine curve. Yesterday, or we've been doing period is 2 pi over b, all right? 2 pi divided by b would be 2 pi divided by pi over 8. But again, I don't like dividing by pi over 8, so what do? Times by the reciprocal, so that's 8 over pi. Do you see that somewhere else in what we did? Yeah, we already times by the reciprocal and got 16 right here. So we can see right here that the period is 16. We did that math right there as well. So you can still use the formula to get the period, or it just happens to work out while we solve this equation, which is kind of nice. And you can also see it right here just by subtracting. 28 minus 12 is 16. Okay, so all of these back up that the time it takes to complete one cycle is 16. So on our graph, this is our x-axis. It's going to start at 12. It's going to end at 28. And I said yesterday, all I need you to do is find the middle, which is halfway between 12 and 28. Yeah, 12 plus 28 is 40, and half of 40 is 20. So there's our middle. And then I can take the midpoints of each of those, and now I have my 5 x values that I can graph my sine curve. What's the sine song? Middle, high, middle, low, middle. So we go middle, high, middle, low, middle. Okay, so does that seem easier? I think it's a more straightforward way of doing it. Okay, so I got one more to do. So here's the second one. F of x equals 30 cosine of 3/4 times the quantity x plus 4 pi over 3. And then minus 10. So again, this has all the different transformations. We have an A and a B and an H and a K. And I'm going to start by getting my vertical axis. What's my midline going to be? -10. So right here is -10. That is the midline. That is the K value. Always, always. And then what's our maximum going to be? Good. The maximum is going to be up to 20 because we just have to add the A value, so adding 30 to that, or subtracting the A value. What's our low or minimum going to be? What's it going to be? -40. There we go. Okay. All right, so we have our little midline, so our little pretend midline axis there. And now to figure out what my x cycle needs to be on the x-axis, I can simply set up this little compound equation. Normally we start at 0 and end at 2 pi, but everything with x affects those starting and ending points. So 3/4 times x plus 4 pi over 3 will help me get my new starting and ending points. What are we going to do first? Yeah, multiply by the reciprocal. So we can multiply everywhere by 4 over 3. 0 times 4/3 is 0. And what is 2 pi times 4/3? Yep, 8 pi over 3, multiplying straight across there. 8 pi over 3. And then how do you get x all by itself in the middle? Minus 4 pi over 3, minus 4 pi over 3, and minus 4 pi over 3. So 0 minus 4 pi over 3 is negative 4 pi over 3. X is alone. And 8 pi over 3 minus 4 pi over 3 is 4 pi over 3. How'd you get 2?
No.
Okay. 8 minus 4. 8 pi's minus 4 pi's is 4 pi's. Okay. So here we have one period. What is the length of this period? Yeah, it's right here. It's 8 pi over 3. And again, you can get that just by subtracting. 4 pi over 3 minus a negative 4 pi over 3 gives you your 8 pi over 3. You can get it by subtracting. You can use the formula, lots of ways. It appears right there. But anyway, here's our starting. So we start at negative 4 pi over 3. It's going to end at positive 4 pi over 3. And what's right in the middle? 0. That's an easy one. And then we can put our other 2 midpoints, and now just sing the cosine song. High, middle, low, middle, high. All right, for me, I think it's just, this is how I normally teach this. And I don't know why I decided to do it a little different for Delta Math, but it works just fine on Delta Math too. So, do you have questions for me? Does this seem easier to you? Right, we're good at solving equations, so that's why I like it, because we're good at that. It works for tangent as well. These are your asymptotes, your negative pi over 2 and positive pi over 2, and you can figure out where your first 2 asymptotes are for a tangent function as well. But the tangent graphing is actually really, really easy if you just do it in order. So, all right, you guys. Please, I have an extra credit worksheet if you want to do an extra